Hey guys, welcome back to stm32 coding for everyone. So in this tutorial, I'm going to show you how to quickly configure your stm32 microcontroller or your nuclear board to be able to handle an external interrupt. So, well, what is an external interrupt, or what is an interrupt? Like right now, I'm speaking to you, I'm recording this tutorial. My son or my daughter might decide to walk into the room, and that will be an interruption. Now I will have to find a way to handle that interrupt without losing the focus to what I'm doing. So I will make a hand gesture signaling that my son or my daughter must move back outside without disrupting what I'm doing. And once that's done, I'll then return to what I'm doing. That basically means I've handled that interrupt and I've returned to the process. Now, as you can see, the kernel mode here is also stating exactly the same thing. So you have an external event that's occurred, right? So the process was being executed. Now an external event occurred, it basically disrupt the process flow. So now the kernel here is going to handle that external event by handling the interrupt. Once that's done, it leaves the external interrupt handler. And once that's done, it will then leave the exception or interrupt handler function and go back into the process. As simple as that. So I have to come back between these two configurations here, the RCC and sys. First, I go into the RCC and I have to select on the high speed clock. I'm going to select a bypass clock source. And on the low speed clock, I'm going to select the crystal and ceramic resonator. So that basically means on the external low speed clock source, I'm using that crystal oscillator right there. Now you can see there are some configuration loaded. And for the system here, I have to select my debugger. So which debugger I'm using? I'm using the ST-Link, which use the SWD, which is a serial wire debugger. So I select serial wire debugger. Now you can see I've got some pin configuration that have now been loaded. Right now, the only thing that is now left here is basically to set up the pin that will be handling our external interrupt and the pin that will execute what we want to do. Okay, so now we want to trigger an external interrupt when a button is pressed, okay, which is a user button, the blue button. We've got that function to handle an external interrupt, PB0 and so forth. Okay, the same goes with PA1, PF1 and all the way to PF15. Now remember, your button here is connected to PC13, okay, as per the schematic reference of this nuclear board. Now, if you're not too sure how to basically see which pins your button is assigned, I've got tutorial where I've basically explained exactly where your LEDs and your buttons are basically. Nested vector interrupt controller here is basically what is handling the priorities and how the interrupt will be done, the polling and all of that. So you basically need to find it here. It says external line 15 to 10 interrupt. So we've got the interrupt ranging in this range of 15 to 10. Now you know you are in there. PC13 is within that bracket. So all you have to do is to enable it right there. So we basically done here. You can go ahead and generate your code here. So you just click on code generation and yes. Now you've got your code generated for you with all the configurations. You got your system clock configuration. We're not going in there. Right. The second one is going to be the green LED GPIO port. So that's what's being initialized there. So you're going to now pass it in here. Right. Now from here, you can go ahead and basically compile your code. If all is well, this code should be able to compile. So I'm going to go ahead and build this code. Right, the code is done building and there is no problem. Our compilation went successful and I'm going to go ahead and basically run this or load this code into my microcontroller. So you're going to observe the debugger is going to switch on and that's going to basically start loading. As you can see, successfully load the code. Now our code is now fully loaded. So now when I click on the blue button, we should be able to see the LED come on. That basically means there is an interrupt, and a toggle function here must be called. Okay, so the toggle function is going to be called in our callback here when an external interrupt happen. So let me just dim the light in here so we can see clearly. Okay, so I hit the blue button. There we go. There was an interrupt and an LED just came on. Now